Today is the 15th day of 30-day lead coding challenge, and today we will be solving lead code problem number 238. And it says the product of array except self. And it may look very easy, but there are some constraints, some conditions that lead code has put for this competition and this problem, which makes it of medium difficulty level and not easy. So the product of array except self means that for each index, you are given here a 3-size array. So you will return an equal size array as return value, where the value at ith index will denote the product of all the elements of the array except the element at that index. So for example, if you have 1, 2, 3, 4 and you multiply all the elements of the array except 1, you will get 4 times 3 times 2, which is 24. So first index is 24. Next index, you have to multiply all the elements of the array but 2. So you multiply 4, 3 and 1, you get 12. Now for 3, you multiply everything except 3, so you get 4 times 2 times 1, 8. Similarly for 4, it's 3 times 2 times 1, which is 6. So here the condition is that no division is allowed, and you have to do it in order n time. Order n time because there are n elements, so you have to update n values at least, so you cannot do better than order n. And if you were allowed to use division, then what you would have done, you would have scanned through this array and calculated what is the product of complete array P. Then in order to find the value of this at I, you would have done P divided by, if this is A, AI. So you know the complete product of the array. For ith, you just need to divide this because you are not including that in the product. But that division is not allowed. So you have to think of something else. So what we will do, we will first look at an order n space solution. And then we will modify our solution to get it done in order 1 space. And both of these are meeting the above two conditions, that is order n time and no division. And then we will see the code for this in C++ as well as Java. Since many of the viewers are comfortable in Java, I will be providing both codes, and there will not be much of difference between these two codes. So let's begin. So how can we solve it? So if you look at any element, let's say I look at this 12, which is corresponding to this 2. So what this 12 denotes, this denotes the product of all the elements of array except 2. And what is that equivalent to? That is equivalent to multiplying the product of all elements to the right of this and product of all the elements to the left of it. And this will be true for each of these. So if you are looking at 2, it will be 1. Let's write 2 in different color. And write product in different colors, 3, 4. In order to calculate, you need this blue and green products. Similarly, for 1, I should have written 1 earlier. Everything will be in green. There is nothing to the left. So 2, 3, 4. And for 3, it will be 4 and 1, 2. And for 4, so here blue denotes all the elements to the left of it and green denotes all the elements to the right of it. And we have to take the product of all of this. So the product of blue is 1 times product of green is 12. Similarly here, the product of green is 24 and product of left is nothing. So if for leftmost and rightmost, we will keep it as 1. And here right is 4, left is 2, and here left is 6, and right is nothing, so we will keep it 1. So there is a order mismatch here. I should have written 1 here, but let's. So here it's 24, then it's 12, here it's 8 and 6. So you see exactly this value, 24, then 12, then 8, then 6. So what we need to do 2 scans of this array. In one scan, we will keep all the prefix products. So we can have 2 arrays of same length as this. So here Li will denote product of all elements to the left of ith element. And we will initialize the first with 1 because there is nothing to the left of it. If we reach here, it's the product Li minus 1 times I minus 1, right? So for example, you know the product of all the elements to the left of 3, okay, which is 2, which is captured in L value, Li. So in order to calculate the product of all the elements to the left of 4, what you will do, whatever was the value of Li of 3, you multiply that with 3. So L of 3 was denoting 2, so you multiply that by 3 and you get that for 4. So basically you are keeping a running prefix product. So for 1 it's 1, nothing to the left, base case. For 2 there is just one element to the left, 1, so its product is also 1, which is 1 times the previous element. And for 3 it's the value for 2 multiplied by 2 itself, or you can see here also it's 2. For 4 it's 6. So this is the prefix product. Similarly you will do suffix product. So for 4 there is nothing to the right, so we can keep it 1. For 3 it will be 4. For 2 it will be 3 and 4, that is 12. And for 1 it will be 2 times 3 times 4, which is 24. And both of these will take order and time, because here we will be iterating from left to right and always multiplying one element to the previous element, previous value. And here we will start from right to left. So now we have the prefix and suffix product. So in order to calculate the result of I, we will simply do Li times Ri. Why? Because Li denotes, if we are looking at this element I, so Li denotes this part, the product of this part. And Ri denotes the product of this part. And that is what we are calculating. So we will simply do Li times Ri. Then we will optimize this further. So here you see that we are using order n space. These are the 2 extra n size spaces. So how can we get rid of these? So we will anyway, we will be returning this result, which will be of n space, but LeetCode clearly mentions, as you can see here. So no division allowed. And the output array does not count as extra space. So you can use the output space. So we will do exactly that. So how can we modify it? So let's see. So what we will do, so first we had created the prefix product. So what we will do, we will have just one array. We can think of it as result. And in first pass, we will build exactly the prefix product array which we did earlier, which was L in the previous slide. This one. So we are building this L. So initially this result will be exactly same as L. Then it's 2, then it's 6. So this result currently denotes equivalent to L. And now what we need to do for each element, we need to multiply what is the product of all the elements to the right. So for this, there is nothing to the right. So this will come as it is, 6. And we can have a product variable. We can initialize it with last element. And we can start our iteration from here, because we know for last it will be same as this. Everything is to the left. So we come here, we see what is the product of all the elements to the right. It's 6. So, and what does this 2 denote? This 2 denotes the product of all the elements to the left of it. So we have the product of all the elements to the left of it. We have the product of all the elements to the right of it. So the result should be this 2 multiplied by 6, which is so now this is denoting this ith element. For example, here's 0, 1, 2, 3. So this result 2 denotes the product of all the elements to the left of 2. Now what additional thing we need to multiply to each of these elements? The product of all the elements to the right of 2. So we have Li, but we don't have R. We will calculate it on the fly. So for rightmost element, it will be same, because there is nothing to the right. So everything is to the left. So it will be same as here. So actually we will start iterating from here. And we will keep a running product. Right product. And we are starting from here. So the product of all elements to the right of it will be this last element. So we will initialize it with, this is our nums vector, this one. So it will be nums n minus 1. So we will initialize it with the last element, because we are starting from second last. So we already have this 2, and this 2 denotes the product of all the elements to the left of this element, third element. And this denotes the product of all the elements to the right of it. So we just need to multiply it. So what is nums n minus 1? It's 4. So we will multiply 2 with 4 and we will get 8. And then when we come here, we will update the running product of the right. We will just multiply the last element that we processed. And in this case, it was 3. So we multiply, so right product, we multiply by this 3. So we got now 12. So this is the left product, this is the right product, multiply them, we get 12, and update the right product. So this time we multiply by 2, because we have reached here, the first element. So this is now part of the right product. So we multiply that and we get 24. And you just multiply this prefix product and this suffix product and you get 24. And this is the result. So here we have not used any extra space other than the result itself. We have just kept modifying result and we are returning it, and that is allowed, and that will be order 1 space. And this one was order n space. So let's write code for this both in C++ and Java. First, I will write the code in C++, and first I will give the order n solution. Int n equal to nums dot size. Then we will have two vectors L of same size n and everything initialized to 1. Similarly, vector R, n size, everything initialized to 1, and one result vector. Now we will build the left product array, and this denotes right products. So for leftmost element, the left product we are initializing with 1, everything initialized with 1, and we will update the values from second element onwards. I less than n plus plus I, L of I equal to L of I minus 1 times nums I minus 1. Similarly, for I equal to n minus 2, which is the second last element, rightmost we have already initialized, I greater than equal to 0, minus minus I, Ri, same as this, we are writing in the same format, plus 1. Here we are iterating from right to left. So previous denotes I plus 1. Here previous denotes I minus 1. So we have our prefix and suffix products. So one last pass of the array, I equal to 0, I less than n, plus plus I, result I is simply product of all the elements to the left of I, which is Li, and product of all the elements to the right of I, which is Ri, and then return result. So we got a compilation error because we did not add int here. And let's run it again. So it works for this case. So let's go ahead and submit it. Then we will update this to not use extra space. So this solution is valid and it's accepted. Now let's get rid of the extra space. So we will get rid of these. We are allowed to keep this result. You can see here the output array does not count as extra space. So we have kept this result. And first we will populate this result as prefix. So no change here. So after this, at this point, at the end of this loop, this result of I denotes the product of all the elements to the left of ith element. Now we need to add the right products. So we will have the running product int right product equal to last element, and we will start from second last element, n minus 1. So we are starting from second last and going till beginning. So what we need to multiply is, so result I is already denoting the prefix product. So we will just multiply it the suffix product or the product to the right. So write product. Now this the I which we have processed now holds the final result, but the I's which have not been processed are still holding the prefix product. So we will keep iterating, keep decrementing I, and we will keep multiplying the products to the right. So initially the product to the right was just last element. Now the second last element is processed, and we will process the third last element. So the second last element which we just processed should be multiplied to the running product, because we have shifted one element left. So one element extra was added to the right product. So right product will be updated here. Nums I. This is for next. So we calculated the result for I, then multiply it to running product, so that for next element we have this nums I multiplied to the right product. And finally we will return the result. So you see, it's the same idea. We are just saving our space. Let's run this. And it again works. Let's submit it. And our solution is accepted. Now we will do the same thing in Java, everything. First we will see the order n space implementation. So here it will be nums.length. And then the same as earlier, we will have one L and one R. So these are left products. These are right products. And finally we will have a result. Then L0 equal to 1, and left of 0 is nothing. Similarly, right of n minus 1 is nothing. Both are initialized to 1. And for int I equal to 1, starting from second element, I less than n, I plus plus, Li equal to Li minus 1 times nums I minus 1. So we now have the value for product to the left of I, all the elements to the left of I and all the elements to the right of I. And finally we will just need to multiply element wise both of these prefix and suffix product to get the result for I. So int I equal to 0, I less than n, I plus plus, result of I is nothing but L of I times R of I, and return result. So let's run it. This was our earlier accepted from C++ submission. Now we are submitting in Java. And this is accepted. So now the last thing is to optimize it for space. And as earlier, as the C++ solution, we will get rid of these. And first we will initialize the result. So wherever there is L, you can simply replace with result. So in first pass, we will calculate all the prefix products, and then So result I currently denotes the product of all the elements to the left of I. It's same as L earlier. And now what we will do, we will have a running product, which is a right product equal to, it will be the last element, which is nums n minus 1. And we will start from second last element. For last element, it's same as the prefix product, because for last element, there is no element to the right. So the product of all elements except that element is same as the product of all the elements to the left, which this result I denotes at the end of this loop. So we don't need to process the last element. We start processing from second last element. And for the second last element, the running product to the right of this is simply the last element. And for third last element, we will just multiply it, the second last element. So let's write that. So result I, which is currently holding the prefix product, we just need to multiply it with the right product. And we are done. And we also need to update the right product for next element. And then return result. Let's try it. And it works. Let's submit. And this solution also accepted.